In this module, we will be explaining about threaded trees and how they can be traversed. In general, we will be having two types of threaded binary trees. They are known as right threaded binary trees and left threaded binary trees. In the slide, what we have shown is an example for right threaded binary tree. If you observe that there is a pointer for every node to their in-order successor. For example, D. For D, there is an arrow is shown in the slide which points to B. So that is, after processing D, will be processing B in order traversal. So thus the pointer is now pointing to B. That is, D's right becomes B. Similarly, for B's right becomes A, vice versa. If such a structure is seen, it is called as right threaded tree. Similarly, we do have left threaded trees also. The use of thread concept in binary trees will help us to traverse the tree in a non-recursive way. In this example, we try to explain how a threaded tree can be traversed in a non-recursive fashion. The algorithm is given in the slide. Step 1. For the current node, check whether it has a left child which is not there in the visited list. If it has, then go to step 2 or else go to step 3. Step 2. Put that left child in the list of visited nodes and make it your current node in consideration. Go to step 6. Then step 3. For the current node, check whether it has a right child. If it has, then go to step 4, else go to step 5. Step 4. Make that right child as your current node in consideration and then go to step 5. Step 5. Check for the threaded node and if it is there, make it your current node. Step 6. Go to step 1 if all the nodes are not over, otherwise quit. So these are the steps involved in this algorithm. A function in order traversal of this threaded tree is also included in this slide. We consider the node of the threaded tree to have the following data members, that is left, value, right and thread. Value is the key value of the node and left, right, thread, etc. they are all node type of pointers. The algorithm is given in the slide. Let us assume that we are starting from the topmost node A. Node A has a left child B which is not visited. Thus, it is kept in the list of visited nodes. Now, we visit the node B. Rather, we call this function on B. B has left child D, which is not visited, thus it is kept in the list of visited nodes. Now, when we apply this algorithm on D, node D has no left child. Also, it doesn't have right child, and thread link is pointing to B. Thus, B is made as current node, and we output D. Node B has left child, but it is in list of visited nodes. Thus print B. Also B doesn't have right child, and thread link is pointing to A. Thus A is made as current node. Now node A, if we verify, it has left child, but it is in list of visited nodes. Thus print A. Also A has right child C. Thus C is made as current node and kept in list of visited nodes. Node C has left child E, thus it is kept in list of visited nodes, and E is made as current node. Node E has no left child, thus print E. Also E doesn't have any right child. However, thread link is pointing to C, thus make C as current node. Node C has left child, which is already in the list of visited nodes, thus print C. Then set current node to some other thing. So like this, if we observe that with the help of the threads, we are traversing the threaded tree, and we have not used any recursive call. We have used the while loops only, that is the iterative solutions only. Thus, if we happen to have threads like this, then tree traversal can be done iteratively instead of recursively. So in this example, we have explained how a right threaded tree can be traversed iteratively, and we can achieve the in-order sequence. The in-order sequence is given in the slide as DBAEC. Like this, we can use threaded trees to get tree traversal easy. That is, instead of recursiveness, we can employ iterativeness. Iterative solution is possible.